Good morning, Year 4. It's Mr. Smith here, second science lesson of the year. Continuing our topic all about sound. This lesson is going to include 3 different videos, which I will attempt to record for you through my laptop. Sometimes the quality might not be great, so what I will do is put the links for all 3 videos underneath here. So if the quality isn't great when you watch it on this video, skip it, pause at the end of that video, and then click the link yourself underneath. I hope that's clear. As always, if you're stuck, any problems, just send a message on the Year 4 Teacher Support Chat in Teams, and one of us will be there to help. Okay, let's get going. So our date and title are on the screen now, please. So pause the video and write that in your books. Excellent. Okay, some total recall for you to try and remember the things we've previously learnt. So pause the video, have a go. Okie dokie, very good. Well done, everybody. And let's move on. So our learning foci for today, definitely listening again. We're going to be using that a lot in our sound unit, and more absorption, really trying to get focused completely and utterly on the tasks. So here are some key vocabulary. I'm going to quickly read through them. If there's any words you're unsure of, please look them up online on an online dictionary so you're clear about them. Sound, source, solid, air, transmit, vibrations, sound waves, medium, travel, particles, water. So today we are going to learn about how sound travels. How do you think sound travels? Pause the video, have a little think, maybe talk to someone else at home if they're available and not too busy. Okay, right, well, we're going to find out. Now, to help us, I'd like you to ask someone at home if they are able to help you to play a game for just 2 minutes. If somebody's busy working or not available, it's no problem at all. Just fast forward past this part of the video. But if you can find someone to help you, fantastic. All you need to do is this. Put your head, I've put heads, it's just one. You've only got one head. You must put your head on the desk and close your eyes. Whoever it is helping you must silently tiptoe around the room and then knock on a table or a door or a wall or something hard, and you have to try and point in the direction of the sound. When they stop knocking, look up and see if you are correct. And you can take it in turns, have a couple of different goes, and of course when you're doing the knocking, please move around and try and see how easy or difficult it is for the listener to detect the direction of the sound. On the last few times, try it with a very faint sound, a soft, gentle tap. Can you still point in the right direction? Okay, well done. I hope you managed to play the game and enjoy it. Maybe you might be able to answer these higher order questions. So how might you know where the sound was coming from? I'm sure lots of you are very good at this. So how? Try and think. Exactly how were you able to know where the sound was coming from without looking? And also, how did that sound travel from the source, the person knocking, all the way to your ears? It's a good place to pause the video, have a think, and maybe a discussion with someone at home. Okay, so this picture here shows us a tuning fork. It's made of metal, and when they're hit against a hard object like a table, they make a sound. Oh, my typing's not very good today, sorry. It's a bit like when we pluck a guitar string, that makes a note. That's just what a tuning fork does. And some musicians use them to help tune their guitars or keyboards or pianos. So we're going to watch a video, and it's going to be a man showing him hitting 2 different tuning forks, and it will show us that all sounds travel when objects vibrate. So like I said earlier, I'm going to play the video. If the quality is not very good, please just pause it, click on the link below, and you can watch it in your own browser.
Hey you guys, Mr. Rees here. So I want to do a demonstration of sound waves for you. And to do that, I've got these devices. They're called tuning forks. Each one produces a different frequency. Can you predict which one has the higher frequency? I don't know. Think about it. All right, let's try the little one first. So I'm going to bang it on the table, listen to the sound. Ooh, yeah, that hurts my ears from here. All right, and then let's try the bigger one. This one's longer. So what did you predict? Yeah, this one's the lower frequency. Okay, the longer it is, the lower the frequency. Remember, frequency is vibrations or pitch, right? Okay, you can do something really cool with these. I'm gonna take the bigger one. I've got a little bowl of water here. This is gonna get a little crazy. I'm gonna take this and I'm gonna hit it hard on the table. And I'm gonna put it in the water, watch. Oh, do you see the water shoot all over the place? I'm gonna do it one more time. You can't see the forks moving, but when you put it in the water, you could clearly see the energy and the speed at which those forks are moving when it has that sound. So let's try the little one just for fun. Okay, here's a little one. Probably not going to move as much. Let's try it again. Whoa, that one worked good too. All right, hope you guys enjoyed the video. Take care.
Okay, what a cool video. So we saw the tuning forks vibrating when they made a sound. And in fact, they're vibrating so much, so quickly that the water splashed everywhere when they touched the water. So what does this tell us about other things that make sound? Have a good think, maybe pause the video and chat to somebody else. Okay, and also have a look at this picture, and it's a bit of a clue. What do you think you call the path of sound vibrations? Because you may have figured out with the video of the tuning forks, anything that makes a sound produces and causes vibrations, sound vibrations. Now they travel, and actually they travel sometimes to our ears where we hear them. So what do you think that path is called? Well, it's actually called a sound wave. Sound is a type of energy. Sound travels through a medium, like gas, solid, or liquid, by causing particles around the tuning fork to vibrate, which then causes other tiny particles to vibrate, which then eventually travels all the way to our ears in a sound wave. So sound must travel through a medium like water or air, or even through a solid, like string or a telephone wire. Another higher order question, lots of thinking today. Pause the video and have a think. Why must sound travel through a medium? Well, we usually hear sound that has travelled through the medium of air, which is a gas, but it can also travel through solids and liquids. But this happens at different speeds. And this is a bit like using a microscope to have a look at a solid, something like wood or stone. This is what a liquid looks like. These are all the tiny particles inside a liquid. They're a bit more spaced out. And in a gas like air, they're really spaced out. Okay, so sound waves can travel through a gas like air quite easily. Now, what do you think would happen if we put an alarm clock in a vacuum? No, not a vacuum cleaner, but a vacuum is a container with no air in. All the air has been removed or sucked out. What do you think would happen if we put an alarm clock in there? Have a think, pause the video, we're going to find out. Okay, just like before, I'm going to play the video. If the quality's not great, click the link below to watch it yourself.
The sound of an alarm clock travels to our ears through vibrating particles in the air. The clock is placed within a capsule, and the air is sucked out, creating a vacuum. What happens next? Without air particles for the sound to travel through, we can no longer hear the alarm.
Okay, pretty cool, hey? So that answers that question. If there's no medium, so no gas, no liquid, or no solid, there's no sound. And here's a picture of a speaker in the middle of an empty room. And here are the particles, and the vibrations are passing from the speaker and traveling in sound waves away from the speaker. And if you were stood in the room over here where my mouse is, you can see how you would get some vibrating particles and a sound wave reach you from the speaker. Another higher order question: what would happen if I played music in space? Pause the video and have a think. Well, of course, in space is a vacuum. There's no air, so actually you wouldn't hear sound. Fascinating, hey? Okay, to help consolidate our learning, one more short video, just like before. The link is below in case you need to watch it on your device if the quality's not fantastic. Here we go.
Why can't we hear this alien scream in space? And have you ever wondered when you make a sound like ooh, how does the sound actually get into your ears? Watch what happens when the spaceship crashes on Earth. That's more like it. So why is it that we can hear the alien scream now? Well, sounds are made from vibrations. We can't see vibrations, but if we did, they would look a little like this. Sounds are made when objects vibrate. Sound waves make the air around vibrate, and the vibrations enter your ear. You hear them as sounds. In space, there is nothing for the sound waves to travel on. That's why we couldn't hear the alien scream.
Okay, interesting. So, time for our activities, and I'm going to switch over to a Word document to show you the bronze, the silver and the gold challenge for today. So, if you're going to go for bronze, I would like you to copy these pictures and the text, but put them in the right order into your books to show how sound travels. And you might make a flow chart or arrows between the 5 pictures once you've put them in the right order, and it will show and explain how sound travels from a guitar all the way to your ear. Pause the video and start that now, please, if you're going to do bronze. If you're choosing silver today, it's the same thing as bronze. You're going to copy these pictures into the right order into your books, but you have to come up with the explanation for each picture. So you have to explain what's happening here. What is happening to these sound particles? Why? What are the little lines? Explain the vibrations being passed from one particle to another. Okay, so you're again going to create a little flow chart, the 5 steps, explaining how sound travels from a guitar to your ear, and try to use some of the technical vocabulary from this lesson, please. Pause the video and have a go if you're going for silver. If you're going to go for gold today, very similar, you're going to design your own poster or flowchart with at least 5 pictures and text explaining how sound travels from a source, like a guitar or a speaker, to our ear. Please try to explain lots of the technical things we've talked about, including vibrations, particles, sound waves. Pause the video now if you're going for gold. Okay, well done. I hope your flowcharts and explanations of how sound travels from a source, like a guitar, to your ear are looking fantastic. Please, as always, take a picture and send that through in Teams to your teacher. They would love to see them. And finally, a really nice STEAM challenge. I'm sure any adults in your house will know about this. See if you can design and make a string cup telephone. If you Google string cup telephones, you will find lots of different ways, little video clips and instructions to help you make them. They're really easy. If you've got 2 paper cups and a piece of string, that's all you need really, and a pencil to make the holes. You can use all sorts of different containers. If you don't have paper cups, I'm sure you'll be able to come up with something at home. Okay, you don't have to do this. It's an extra STEAM challenge linked to sound. And what you'll find is if you can get it working, you can send secret messages to the person on the other end of your string cup telephone. Again, if you manage to do this, please send a photo through to your teacher on Teams. They would love to see it. Okay, that's the end of today's science lesson. I hope you enjoyed it, and I will see you next week for lesson 3 of our sound unit. Take care, bye.